Welcome back to the class in electric vehicles and hybrid electric vehicles. In this lecture, we are going to discuss about the impact of electric drivetrain on sources of power. Impact is nothing but what are the different changes occurs in sources of power. Generally, there are two types of sources of power. One is the grid, another one is the renewable energy source. Grid is nothing but somewhere we are generating a power by means of hydro power plant or thermal power plant that we are transmitting and distributing and utilizing for the charging of electric vehicle. So another source of getting electrical power is by means of renewable energy. We can use a solar panel to generate electrical power. That also we can use for the charging of electric vehicle. Now here, what are the different changes occurs in the grid? The electric drivetrain is charging and discharging. That we are going to see now. First, let me see what is meant by electric drivetrain. Electric drivetrain is not a single component. It is a group of components which are giving a propulsion for the wheels of a vehicle so that it will be moving against the roadway force. In the modern drivetrain is consisting of battery. So whenever we are saying the battery means this power, here we are using one motor to get the mechanical output. That motor may be the DC motor or the AC motor. Depending upon this motor, here we are using the converter. Suppose here the motor is a DC motor, then we are using the DC to DC converter. Suppose this motor is the AC motor, then here we are using the DC to AC converter. The clutch is used in a vehicle to make the speed of a motor is equal to the of a vehicle along with a single gearbox. In case of electric vehicle, this is the advantage. We are using only the single gearbox because we can able to control the speed of a motor by means of a control system. Here. The total thing is nothing but a electric drivetrain. This is the axle, this is the differential, this is the drive shaft, this is the wheel 1, this is wheel. The shaft of a motor is coupled to the axle of the wheel through the clutch and the single gearbox. Now here we are going to see how this electric drivetrain, nothing but electric vehicle is going to affect the sources of power. So whenever we are saying the battery, it will be charging and discharging. So we have a charged battery along with the vehicle. Whenever you use that vehicle means the battery will be discharged. Again we have to make it charge. But when you come to the battery is a non-linear high power device. When it is charging, it is taking a high amount of power. The same manner, the characteristics of a charging of battery is non-linear. So that's why it is going to affect the grid. Now we are going to see what are the different effects of a grid. There are different technical issues when the EVs are charging with a grid. One is voltage instability. Second one is the voltage sag. Third one is the harmonics. Fourth one is the losses in a distribution system. Fifth one is the distribution transformer rating and cable rating. Now let us see the voltage instability. Voltage instability is nothing but there is a mismatching between the generated power and load power. So whenever the EVs are charging at a charging station, it will take a high amount of power. There is a possibility of mismatching of power between the generation and the load, which causes to the oscillations in a grid. Sometimes, if these oscillations are very high, it leads to the blockout of the power system. Grid always requires a constant impedance load. Nothing but the current which is taken by that load is proportional to the voltage. Suppose if you take the industrial loads and household loads, almost all the constant impedance load. But when you come to the EV, at the time of starting, it is taking a very high amount of power. So there is a possibility of imbalance between the generated power and demand power. Next, one more point here is that when the EVs are charging, there are two modes of charging. One is level 1 charging and another one is level 2 charging. Level 1 charging is nothing but a slow charging. We are charging the battery at 110 volts. So it will take the less amount of current to charge the battery, it will take more amount of time. Customers are demanding the fast charging. So whenever we want to charge the battery with a very fast means we have to decrease the voltage so that the current will be increases for given amount of the power. So the battery will be charged very fast, but it is affecting the grid. Now how we are going to overcome this type of problems means damping the oscillations due to the charging and discharging of the vehicles. Install the fax device at place of charging stations where the charging and discharging of the more vehicles will be occurred. we try to damp out that oscillation. Next, coordinate charging of a, suppose if we take a one area, in that area we are assuming that charging station is there. From morning 10 o'clock to evening 4 o'clock, more amount of power will be taken by that area. So in that area, we should not charge the EVs in that period. During the night time, the power taken by that area will be decreases. So in that area, you can use the EVs to charge. Nothing but we can able to coordinate the charging stations so that when the peak load power will be low. So because of this heavy power drawn by the EV charging stations, the voltage at the terminal will be decreasing. That we can maintain by changing the tappings on a distribution transformer. The main effect of this one is the voltage instability. Nothing but the voltage at the terminal will be drastically decreased. So we can use the voltage controller with the latest control technique by means of fuzzy control, neuro controller, so that we can maintain the voltage at the terminals will be the almost constant. So one more important parameter how we are going to avoid this one means by means of a solar energy. Locally generated power, that power you can give to the charging stations so that the charging stations will be taking less amount of power from the grid. The second one is the voltage sag. We know that the EV is a high power device, it will take a high amount of current at the time of starting. High current is drawing from the distribution line. There is a decrease in a voltage in RMS value for the 1 to 2 cycle. That is nothing but a voltage sag. It leads the power quality problem in a distribution line. Suppose the same distribution line is giving the power to the remaining loads means the performance of the remaining loads also will be affected. Suppose the same distribution line is giving a very sensitive loads means then the sensitive loads will be tripped. So to avoid that one, control charging of EVs to be done. Suppose we have a one charging station where we have to charge the nearly of 20 electric vehicles. We should not try to all 20 electric vehicles on the same time to charge them. We can able to coordinate so that the current taken by the charging station from the distribution line will be decreases. It is not going to affect the voltage. Next, installation of the fax device. Already we know the fax device is nothing but a flexible AC transmission. By means of the fax device also, we can mitigate the voltage sags at a distribution line. The batteries are charging in EV. We know that the current drawn by the EV is a non-linear current. Nothing but even though if you apply the pure sinusoidal voltage to the EV, it will take a non-sinusoidal current. Nothing but it is consisting a harmonics. When the non-sinusoidal current will be drawn by the EV stations from the grid, the voltage also will be the non-sinusoidal. When the voltage at a terminal is non-sinusoidal means it is consisting of harmonics. It gives a power quality call. Same power with a non-sinusoidal voltage if we are giving to the load at a local area, then it is also affecting the remaining load. The harmonics in a current waveform we can measure by means of a THK of that current. So what are the different methods to overcome the harmonics injected into the distribution line when the EV stations are charging the electric vehicles means prefer the level 1 charging for the electric vehicles and coordinate control of penetration of the EV to the grid. We should not keep all the EVs at the same time to charge the batteries. Losses in a distribution system. So when the EV is connected to the grid, it is taking a high amount of current, nothing but the current also will be carried by the distribution line will be. EV charging station will be away from the local area. By means of transmission and distribution system, we are transmitting the power to the electric vehicle charging station. When the EVs are charging in the station, it will take a high amount of current. So the current passing through the lines also will be increased. Losses also will be increased. How we are going to calculate this losses in distribution system is, so without connecting the EV, we are going to find out how much is the loss occurs in the distribution system. So without connecting any EVs, first we are finding how much is the loss in the distribution system. Next, by connecting the EVs to the distribution system, we are finding how much is the loss occurs in the distribution system. If we make a difference of these two, then we can find out how much loss occurs in the distribution system due to the EV stations. That is very, very high. Now, how we are going to overcome these losses in the distribution system? The local generation is required. Nothing but by means of solar energy, we have to generate a power that we can use to charging stations to charge the EVs. up to some extent we can decrease the losses using the charging station during the non-peak power demand. Distribution transformers and cables. See, generally the distribution transformers and the distribution lines and cables all are designed in old time. By that time, they considered only the household loads as well as industrial loads. They were not considered the EV stations. So whenever we are installing EV stations, which are taking the high amount of the power from the grid, when the vehicles are charging, it is going to affect the transformer. The heat in a transformer will be increases because of the EV station. The heat developed in a transformer is not only depending upon how much current is passing through the transformer, it is also depending upon the atmospheric condition around the transformer. The same manner cables also. Make sure that when the stations are installed in a particular area, the technical people has to take care about what is the rating of the distribution transformer. If it is not, then you have to replace the transformer with a high rating, or you have to operate one more transformer parallel to the existing transformer. These are the different effects of a EV stations which are required to charge the battery in an electric drivetrain on a grid side. So thank you very much for watching this video.